Oscar is the store manager of Dunkin' Donuts, and he is asked to determine the number of donuts to be cooked per day to maximize their profit. Now, he is able to determine the average sales per day and the standard deviation. So, the donuts will cost $7 to cook per dozen and can be sold at $15 per dozen. Now, the donuts not sold within the day are donated to a feeding facility. Sana. Yes, oh, hello everyone. Good day to all of you. In this presentation, we will going to have our topic, our last model regarding the decision theory. No? So, this is the model of the marginal analysis with normal distribution. Before, on our previous model, model number 3, we talked there all about the discrete distribution on marginal analysis. So, for this time, almost the same with the last one, but this time we're going to have a normal distribution. So I hope by this time you are already aware of what is normal distribution. This has been tackled on your basic statistics, the different properties of normal distribution, just like the symmetrical properties, 50% and 50% on both sides. So unimodal and infinite and asymptotic, of course. The value is papunta sa x-axis sa 0 but never magiging 0. Something like that. No? Infinite siya and asymptotic. And ano pa? Unimodal, infinite. That's it, no? Those are the properties of normal distribution. So, just a quick recap on your statistics na basic statistics classes. That's one. Okay, so let's start our discussion regarding this fourth model. Again, marginal analysis with normal distribution. So, basically, this model is used if there are infinitely many alternatives and states of nature. Kaya tayo gumagamit ng normal distribution. Kasi nung ating model number 3 is for finite number of alternatives. No, ang alternatives natin last time is 11 to 20,000 copies na masasolve as sana naalala pa. No? Pero dito, infinite yung number of alternatives na meron tayo. And of course, yung states of nature. That's why we're going to have the normal distribution. Now, this model satisfies the following condition. First, the selling price and marginal loss per unit are known. The mean value is known. The standard deviation is known too, since we're talking about normal distribution. And the probability distribution is normal. No? Yun nga yung pinaka-goal na itong model number 4 to have the forecast or the optimal stacking level using a normally distributed na mga scenarios, no, na mga data na meron tayo. Okay? So, for you to be able to grasp the idea on this topic, let's have our example. Nakakagutom ang ating example for this topic. We have here the Dunkin' Donuts. So, example number 1, Dunkin' Donuts. Now, Oscar is the store manager of Dunkin' Donuts, and he is asked to determine the number of donuts to be cooked per day to maximize their profit. Now, he is able to determine the average sales per day and the standard deviation. So, the donuts will cost $7 to cook per dozen and can be sold at $15 per dozen. Now, the donuts not sold within the day are donated to a feeding facility. Sana all feeding facility. Donuts not sold, no? Doon sa kanila i-donate. Kasi nga, as far as I know, the management of this company, the Dunkin' Donuts, gusto nila laging fresh, laging bago yung siniserve sa kanilang mga customers. That's why we need to have this optimal stacking computation for them to be of service of people talaga, of their customer, na kung ano yung pinabanggit nila, no, is nagagawa talaga nila. And kung ano man yung, para din sa sa branding din kasi yon, no, part ng branding. Okay, anyway, the average sales per day is 200 dozens and the standard deviation is 20 dozens. Now, the question is, how many dozens of donuts should be cooked per day? No, gaano karaming dosena yung kailangan nilang gawin, no? Kailangan nilang lutuin per day. Or yun, per day. Let's have our table of the basic figures. Actually, this came from the problem, no? Nilagay ko lang into table form. First, we have the marginal loss or the ml per dozen. That is in the unit of dollar, and that is 7. So, the selling price is SP, that is 15 in unit of dollars. 2, average sales or per dozen ito, this is not per piece. Take note na in 1 dozen, we have 12 pieces of donuts there. So, the unit or the amount na binabanggit dito is always in dozens. So, average sales in dozens per day, that is represented by mu. Again, when we say mu, that this is population standard deviation. Kapag kasi X bar ang ginamit natin, that only represents the sample. Population mean rather. Kapag kasi X bar ang ginamit natin, that represents the sample mean. Na I hope palinaw pa sa inyo yung pinagkaiba nun, statistically speaking. And the value is 200. Last one, we have the standard deviation of sales. So, we used here the small sigma. This is actually denoting the population standard deviation. Kapag po kasi sample standard deviation yan, that is for letter S. No, letter S yung variable. And the value is 20. Okay? So, the variables that we will be using here. So, of course, i-write natin yung mga variables. Una, yung marginal loss, no? Let's have my pen muna. Let kulay white tayo ngayon. Okay, so first variable is of course ML for marginal loss. Ito na, nakasulat na sa taas. Let's just write it here. So, marginal loss. Okay, next we have SP for the selling price. Next, we have MP. Ayun, MP, hindi siya kasama dito. MP. MP stands for marginal profit. So, we have marginal profit. Next, we have the P of X asterisk. I hope you still remember this variable. This stands for the probability of optimal stock. Okay? Probability of optimal stock. Now, first part of the solution is we need to determine the marginal profit. Again, I hope you still recall the formula for marginal profit. It is just the difference of the selling price and the marginal loss. So, since we have here the selling price of 15, so let's write here 15 minus marginal loss of 7. So, MP value is, we have 8. Then, the unit is dollars. No? So, $8 for marginal profit. This is per dozen of donuts. Okay, so next we have the probability of optimal stock. We need to compute the probability of optimal stock. Just a recall, probability of optimal stock formula is ML or marginal loss over SP or the selling price. Okay, so let's divide these two numbers. ML is 7 and SP is 15. So 7 divided by 15, that will be the probability of optimal stock, which is equivalent to 0.47 or 47%. Now, for the next part of our solution, let's have here our area under the curve. So, for the area under the curve, I hope naalala nyo pa ang itsura ng normally distributed na curve. So, for the area, we just need to subtract the probability of optimal stock from 1 or 100. No? If ever na you're using the percentage, 100% ito. Tapos, gagamitin natin 47%. But since we are using 1, so we will subtract 0.47 lang. Okay? So, 1 minus, ano muna tayo? Variable muna, x asterisk. Then, area equals 1 minus 0.47. This is the area under the curve. Bakit po 1? Dahil ito yung kabuuan ng normal distribution. Approximately 100%, pero hindi siya exact 100. Dahil nga, ang property ng normal distribution is asymptotic. No, hindi siya closed talaga, hindi closed yung dulo, yung magkabilang dulo ng ating tail. Okay? So, value for the area, 1 minus 0.47, so this is 0.53. So, next, we need to solve now the corresponding z value. This is z-score, this is area kasi, and kailangan nating makuha ano yung corresponding na z value nun. So, z of 0.53. So, upon checking, I hope you still have your table with you. No? 0.53, titignan natin nasa loob kung nasaan yung exacto 0.53 or kung hindi man exact yung makita natin, kahit ang kunin lang natin is yung pinakamalapit. Okay? So, we have 0.90 something here. 0.5, 0.53. So, ito pwede. 53.19. If 53.59 ang pipiliin, medyo malayo na sa 53. So, 53.19 tayo. Mas mababa. Wala na, no? So, 53.19. Nandito siya. So, ano yung corresponding na z-score niya? So, since this is the cell, this is 0. So, first row tayo. 0 plus 0.08. So, meaning to say, the corresponding z-value is 0.08. Ito yung z-score niya. Dito sa graph, no, ito, yung value na yan is 0.08. And take note that the area na nakuha natin is the area between negative infinity up to the z value natin, which is 0.08, where the z value is x minus mu over standard deviation over sigma, na yung formula ng z-score natin na inaral sa statistics. Okay, mamaya gagamitin natin ito sa next na step natin. Okay, so ito na po yun ang ating next na step, which is to compute for the optimal stack or the x asterisk based on the average sales and standard deviation. So let's have the formula for the z-score. Kasi kung titingnan ninyo, yung formula sa z-score kanina, ito, kopyahin lang natin. Ang wala lang dyan is yung asterisk ng x. No, kasi x dito is point of interest. Sa atin, yung x natin is yung optimal stock level. So, convert lang naman natin. Lagyan lang ng asterisk. So, let's have here x minus mu over sigma. As you can see, guys, we already have the mu. Ano yung value ng mu? Ito, 200. We also have here yung sigma. Anong value ng sigma? 20. No, after that, we actually have the value of z na, dahil na-compute na natin siya, 0.08 nga eh, from the area na 0.53. Ang wala tayo is yung x, kasi ayun yung optimal stock. Ayun din yung problema natin eh, di ba? Ang tanong, how many dozens of donuts should be cooked? That is x. That is represented by x. Now, ano nang gagawin natin is to convert this formula into a form na kung saan x yung mahanap, x asterisk. Okay, so cross multiplication, we will be having z and yung small sigma, tapos x asterisk minus mu. So, z, sigma, plus mu, lipat sa kabila, equals x bar. So, shift natin yung equation para maging x bar equals z multiplied to sigma plus mu. So, now, anong gagawin na natin is to substitute yung mga meron tayong given. So, x asterisk equals yung z na nakuha natin. We have 0.08 multiplied to the value of sigma, 20. Okay. Plus mu. So, our mu is 200 or the mean. So, let's have here 200. Okay, if you compute this in your calculator, let's have my go-to calculator. Plus 200. We will be having an answer of 201.6. Okay, so let's write here 201.6. And since there's no such thing as 0.6, wala namang ganyan na na tawag dito na dozen of donut dahil ang bilang natin diyan kada isa no 12 pieces is 1 dozen, no? So 2 dozen is 24 pieces, and since ito is unit niya is dozen, there's no such thing as 0.6 dozen unless na bawasan mo yung laman sa loob. Pero sa production perspective, iangat na natin ito. No? So, magiging x bar equals 202 dozens. So, ito po ang ating magiging optimal stock, no? Or ito yung optimal na number of dozens of donuts na kailangan natin i-produce per day. Now, since this is a normal distribution, I will just have here the representation. So, assuming this is standard, this is 1, this is 2, this is 3, this is 0. I hope you're still familiar with this one. So, we have around 0.08. So, ano na lang, estimate na lang. Kunyari, ito yun. At kunyari, pantay din yung sulat. 0.08, ano siya. Yung kaninang na-solve natin, na 0.47 or the 47% na probability of optimal stock, actually, on the data visualization perspective, ito po yun. No, ito yun. 47%. Diba? Kasi 50% itong kabila eh. 50-50. May konting hindi siya nasakop ng shading natin. Dahil nga, this is just a 47%. This is the optimal probability of optimal stock. Probability of optimal stock. So, now, since this is on a standard normal distribution, ang katumbas niya actually in the numbers on the donut na perspective natin, ang 0 dyan, ito yung magiging average na daily sales. No, yung average sales. Which is, if you recall from our given, so average sales per day, ang katumbas nito is yung new na 200. So, ayan. So, meaning itong 0, that is 200. No? And, ang 0.08 natin, itong 0.08 na na-compute, since this is z-score, z-stat, or z-value, those are all the same. Pag sinabing z, na pare-pareho lang yan, iba-iba lang ang tawag. Ang katumbas itong 0.08 natin is this 202 donuts. No? Or dozens pala. 202 dozens of donuts, which is the optimal stock. Now, sir, bakit ang nangyari, ang optimal stock natin is yung critical value, yung z-score? Bakit hindi yung nandito sa pinakadulo? Kasi po, when we say optimal stock, by definition, based doon sa ating na-discuss last time, when we say optimal stock, this is the amount of stocking level na kung saan hindi ka, kapag in-stock mo yun, hindi siya matetenga ng napakatagal. Kasi nga, di ba, we have the idea in the PIE subject ninyo na inventory is a sleeping money, so ayaw natin na natutulog. Yung sakto lang, natatagal siya dyan. Hindi sobrang tagal, hindi rin naman sobrang bilis na may demand pa, no? May mga customers pa, wala ka na maibigay. Hindi na optimum yun. So, ito po yung optimum level, itong 0.08. Na parang yung sa tawag dito, model number 3 before, with discrete distribution, yung optimum doon is yung pinakamababang yes na nakuha natin, na nasa gitna din siya, na nasa center din. Kumbaga, ito yon yung katumbas niya sa normal distribution na curve. So, I hope you get it, and I hope nakuha ninyo. If hindi pa, let's have our second example. Almost the same lang ito with the Dunkin' Donuts. So, I hope you're familiar with Gonuts Donuts. So, Gonuts Donuts. We have here Patricia, which is the shift manager of Gonuts Donuts, and she is tasked to determine the number of donuts to be cooked per day. for them to be able to maximize their profit, of course. And she is able to determine the average sales per day and the standard deviation. So, almost the same with our previous problem. Given si average sales, given si standard deviation, and of course, yung ML, yung SP. And donuts will cost $9 to cook per dozen. So, this will be the, since this is cost, this will be the marginal loss and can be sold at $15 per dozen. So, selling price 15. Donuts not sold within the day are donated to a feeding facility. Sana talaga lahat feeding facility. Ang sarap siguro tumambay sa feeding facility, no? Kung daming donut everyday. Magdadasal ka lang na sana merong sobra. Anyway, so the average sales per day is 200 dozens and the standard deviation is 20 dozens. The question is, same sa kanina, how many dozens of donuts should be cooked per day? Now, sir, halos pareho naman. Inulit lang natin yung problem. Yes, yung problem halos pareho. Pero mamaya, you'll see the difference during the solution. Somehow, there is a difference. Minimal lang naman. Okay? So, for the basic figures, we have the ML or the marginal loss per dozen, which is $9. Selling price or the SP per dozen, which is $15. We also have the average sales in dozens per day, which is represented by mu again. Again, mu is population mean if x bar that is considered as sample mean. Value is 200. Next, we have the standard deviation of the sales represented by the symbol sigma, small sigma. The big sigma kasi is yung parang letter E, no? So, again, sigma, this is the population standard deviation. Kapag sample standard deviation yan, that is letter S. No? And the value is 20. All these 9, 15, 20, 220 values are given from our problem. Okay? So, our variables, let's rewrite our variable that we will be going to have during our solution. So, first ML, which is the marginal loss. Okay? Next, we have the SP or the selling price. And also, next, we have the MP. This is not given. We will go into compute this. This is only a basic subtraction. So, marginal profit. And we also have P X asterisk, which is the probability of optimal stock. Okay, so this will be our variables. First step is to determine the marginal profit. So again, formula for marginal profit is MP equals to SP or the selling price minus the ML or the marginal loss. So what will be the value of MP? Let's have this. SP is 15 minus ML 9. So 15 minus 9, ayun yung MP natin, the marginal profit natin, which is equivalent to 6. No? And unit is dollars. So $6. Now, the next step is the probability of optimal stock. Just a recap for the formula of the probability of optimal stock. It is just the ML over SP. Okay, so substitute natin ito. We have ML na 9. SP selling price is based on our basic figures, that is 15. So 9 divided by 15, that is 0.6 or 60% if you convert this into percentage. Okay, so next step is to compute the area of that optimal stock sa ating normal curve. So the area for the under the normal curve is actually basic lang din, 1 minus P of X asterisk. So area equals 1 minus, ano yung na-compute natin? 0.6. So let's have here 0.6. 1 minus 0.6, basically, that is 0.4. So ito yung area under the normal curve or 40%. Now, next step is to find the corresponding z value. So z, 0.4. Ano kaya ang value nito? And I hope mayroon kayong copy ng distribution table, no? So, ito, standard normal distribution. Let's find for the 0.4. So, 0.5, 0.7, 8, 9. As you can see, guys, dito sa pinaka-corner, we have 0.5. Tapos dito, papunta doon, we have 0.9998, almost 1. Meaning to say, this table is representing a standard normal distribution curve from negative infinity to z. Yun yung binibigay niya. Kasi 0, 0 eh. Ito yun, gitna pa lang yun, di ba? Itong gitna, ito. Dito pa lang sa gitna, no, 50%. Meaning, yung buong left part ng distribution is 0.5. Sinama niya na. And, kung titignan ninyo, ang hinahanap natin is 0.4. 0.5 agad ito. Ibig sabihin, malaki yung chance or yung probability na itong probability na yan nasa kaliwang part ng ating distribution table. Therefore, gagamitin natin yung isang type of the distribution table which is this one na andumi na ng aking delete ko muna. Nagsulat kasi ako. Ayan. So, ayan. Ito yung gagamitin natin. Yung galing doon sa pinaka kaliwa, no, from negative infinity to z value, na ang z value is not on the right part of the normal distribution, but rather on the left part. Since hindi tayo umabot ng 0.5, our area under the normal curve is only 0.4. Okay, so let's find the 0.4. Ayun, meron na, oh. 0.1, 2, 0.3, 0.4. Ito, pwede ito. 4090. Ito na ba yung pinaka malapit sa 0.4? 4090. Ito, mas malapit ang 4050. At ito, 4013. Mas malapit. 3974. Medyo malayo na. Itong baba, medyo malayo na. So, ito ang pinakamalapit. We have 0.4013. And let's check ano yung value niyan. No, ano yung value niyan? Negative 0.2. So, negative 0.2. Let's check. Type it here. Negative 0.2. Tapos 0.05. So, like, 0.2 plus 0.05, that is 0.25. And negative dahil nasa left part tayo. So, negative 0.25. Okay? So, ayan na ang ating corresponding z value. Now, our next step is to compute for the optimal stock or the x asterisk, which is based on average sales and standard deviation. And tulad kanina, no, ipakita natin yung conversion para maalala ninyo. The original formula of z-score is this one, minus mu over standard deviation. Since meron na tayong value ng z-score, which is ito nga, negative 0.25, value of the mu, which is the population mean, which is 200, and of course, the value of the standard deviation or the sigma, which is 20. Meron na tayo yan. Ang wala tayo is yung x-bar, since ayun din yung need natin na kunin. No, dahil nga sa problem, the question is, how many dozens of donuts should be cooked per day? How many? And that is represented by x. In our problem, ang hinahanap natin is optimal solution. So, x asterisk. Okay, I hope that is clear. So, meaning to say, palabasin natin yung formula nito. So, cross multiplication, z sigma equals x asterisk minus mu. So, may minus dyan, lipat sa kabila. C sigma magiging plus equals x asterisk or ano natin, no? Shift natin yung ating formula. X asterisk equals c multiplied to sigma plus mu. And direct substitute na natin. So, what is the value of z? Negative 0.25. So, let's write it here. Negative 0.25. Value of sigma, we have 20. So 20 here. Plus mu. Our mu is 200. Okay, so 200. 200. Okay, so let's have our calculator. Negative 0.25 multiply to 20 plus, let's have 200. Okay, so our answer is 195. Okay, so let's write here x bar, x asterisk rather, letter x. This is letter x. 195. Meaning to say, Patricia, which is the shift manager of the Go Nuts Donuts, should cook 195, should instruct sa mga magluluto nila na 195 donuts ang kailangan nilang gawin per day. No? So, just like our previous example regarding the Dunkin' Donuts, let's have our visualization. Since our z-score is negative 0.25, nasaan siya dito sa curve natin? Let's have first the label. Negative 1, negative 2, negative 3. Negative 0.25, so more likely nandito, banda. Okay, so negative 0.25 na z-score natin. And since that is actually yung katumbas neto, yung optimal na probability of optimal stock, 60%. As you can see, nasaan siya sa curve? No, ito po yun. No, so, if kanina hindi natin na abot yung 0, ngayon naabot natin 0, lumagpas pa nga tayo sa 0. Sakop na siya. Ayan o, titignan ninyo. So, this is the 60%. Okay, so this is the 60% probability of optimal stock. Okay, so 60%. Now, ano katumbas niyan ng mga numbers na yan? No? Itong 0, this is the mu. No? Katumbas niya actually is yung 200. No? And itong negative 0.25, ang katumbas niyan is itong 195 dozens of donuts, which is yung optimal na stock natin. No? So, tulad kanina, hindi tayo doon sa kanan or sa kaliwa, doon lang tayo sa mismong z-score, sa z-value natin, doon natin kukuhanin yung optimal stock. That will serve as the optimal stock. Dahil again, optimal stock, this is the value, this is the stocking level, wherein hindi tayo ganun ka mag-expect na yung stock is magtatagal siya talaga sa atin. No? And hindi rin naman tayo magkukulang. Optimum lang yung yung leveling ng stock niya. So again, 195 is the final answer. Okay, so I hope this presentation makes clear yung ating model number 4, the last model regarding the marginal analysis with normal distribution. And I hope you see the difference between the discrete distribution and of course the normal distribution. Okay? So, I'm looking forward guys in the mastery of the subject. I hope malinaw ito sa inyo ngayon. And I hope natuto kayo sa presentation na to. See you on our next presentation. Keep safe always. Thank you and bye-bye.